Hello, Natroners, and welcome back to another episode of VFX with Natron. Alright, so, we've looked at a lot of stuff. Last time we made this really cool, cloud generator. But this time, I thought we would take it back. I mentioned last time that we used a plugin that came in with the community plugins called, I think it was called Relight or something like that. It doesn't matter. It was a thing to generate textual lighting on something based off of a point on the thing, and it's really currently one of the best ways to do it. But we need to, or to do that type of thing with UVs. We're going to look at today how to convert. We've made displacements and with iDistort and to a degree with STMap, or excuse me, I did the STMap, calling it STMap again. Anyway, we're going to talk about today. We're going to go over and we're going to just look at today's a simple one. We're going to look at making our texture maps, or taking what we get as a result and turning it into an actual form of a bump, and maybe controlling the direction to a degree. There's a little bit of, it goes here or there. Just, anyway, let's get over into Natron. Book. Alright, so here we are in Natron. First thing we're going to do is add a solid. And then we're going to add a ST noise. And so, not an SE noise. So we're going to just use its default, and we're going to connect that up there. And then we're going to blur. We've done this before, but, we have time today. We're going to do a blur. We're going to set the X order to 1. And then we're going to take this, and we're going to just duplicate it, put it here. Put this X order on the second one down to 0. Take the Y up to 1. Then we're going to add in, this is just rehashing to re-engrave this into your brains to get you used to the idea that this is how we do it. This could be turned into a plugin, however. Anyway, shuffle node. Take the A channel, put it into the second one. Set the B channel to AG, which is pulls the green from this one, which is our A channel. We're going to set blue to 0. A to 1, and that gets us to this point. And you're saying, if we don't see anything, well, of course we don't see anything, and I think we just need the multiply. Yes, we're going to put a multiply in here, multiply, and we're going to set the multiply value up to 100, which gives us this, and that is our fundamental UV map of our noise. This is our noise turned into excuse me, into UVs at a value of 100. Now, we're going to also take this, we're going to be converting this to work inside of an STMap. So let's put in an STMap. We're going to put in an STMap. Actually, first thing we're going to do over here is we're going to put a solid. And we're going to put the solid at 0.5. We've done this a million times. Not 0.1, 0.5. So we have a 50% gray, and we're going to be taking this image, or this gray image, and we're going to be offsetting it with a bump. So we're going to apply this to this, and in the process, we're going to have to do a wee bit of math adjustment to fix a few things. One of the things, we'll get to that when we get to that. So the thing we're going to, because this is our source is going to be the gray. We're going to then apply this into an STMap. All right. So here's our STMap, which of course is empty because it doesn't have UVs. And then we apply our UVs, and this is probably going to be just blown into. It's just going to be, we are missing something in here. Well, we're not going to worry about it. It's just what we're seeing is going to be way too heavy. We've taken it, this is actually a bump map right now. The problem is that this is way too heavy-handed. If we took this back down to say 1, it might be a bit more reasonable. Let's take a look. Well, that's still too much. So what I think I'm going to do instead is, instead of adjusting this multiply, because I want to use this multiply as sort of a value to indicate our how much we're going to displace by, what I think a better idea is going to be is to put in a second multiply in here. So we're going to put in another multiply. And this multiply, we're going to reduce the value of this bump until we start seeing this at what we'll consider a reasonable value. Let's put this back up at what we would consider a good value for at 100. Make sure I'm on the right node first. All right, so this is going to be our bump value. So we're going to put that back up to 100. And then what we're going to do is reduce this. We're going to say, consider that a percentage. At 100%, I want this to have a certain depth to it. So we're going to reduce this other one, and you can see it's really crazy calculating right there for a minute. We're going to reduce this one to some sub value, and I'm going to just double check because I already did a bit of this, and I'm going to just get what I have over here. So I've got a, I'm going to just put, we're going to just try this. We're going to put 0.001. We're going to just go with that right now. Bam, we're going to call that 100%. And as you can see, we have our display, or we have a bump map. In fact, that's a bump map that we have made from it. The problem is that this bump map is based off of the directions of our UV map, so to speak. We don't have any way of controlling the light directly, if that makes sense. There's no light source in Natron, so it's sort of just doing it based off of the directions of the UVs themselves. All right, so what's actually determining the direction of this is actually the actual values from this. When we go from our black in the corner, so to speak, up to to the other corner, it's actually basically, if we go to our red channel, we can see the light is coming from wherever at this point, wherever the light side of the map is. We can see this is kind of a bump, right? And it looks similar. It's not the same, because watch this. When we, if we go off of our R and we look back at this, it's not the same. This has got more texture. There's more detail. It's sort of almost like a combination of the two. The other thing we're going to notice is that this is significantly darker than this. Well, it turns out that this bump process, it actually darkens the image a bit. So one of the things I think we ought to do is try to bring it up to, so that we get the full range of our map, so that we see the full brightness, that the brightest brights on this map or on this bump are the same as the brightest, what we would expect the brightest values to be. So what I'm thinking we should do is we're going to just multiply this. So we're going to multiply this, so that our solid going into this is going to be some value or some percentage or some multiple of itself brighter. And the amount that it needs to be brighter, in all honesty, to get it up to maximum would be 4. It's actually taken the gray values, or what I consider the middle grays, down to about a fourth of what they would be. Now that brings it up, in my opinion, too bright, because now our whites are really, really hot, and it doesn't really get that much fall off on here. So I recommend, actually, instead of bringing it up to 4, to bring it up to about half that, which is 2. And we wind up with a much better map. We could, you know, anywhere between 1 and 4 2 and 4 really gets us a nice map. But I did some measurements off of a specific gray that I found in both images that were the exact same gray, and or should have been, one should have been 50%, and it turns out that it was actually about a quarter of the value. In fact, I'll prove this. This is an easy way of proving this, which is we take our multiple and we just set it to 0. Now we've taken this down, so if we take this off, this multiple off, this is just feeding this map into here, completely straight through. So the question is how much has this darkened it? Well, if we roll our pointer over it, we can see over here there's an L value over in this corner. I can't get to it, well, with my mouse, but it's right about where my mouse is right now. You'll see it says L, and it says 0125, which means it's if we started off with a value, if the original one, if we look at that, we scroll over, it says it's 0.5, which makes sense because we said it was a 0.5 value of 0.5. So what that's doing is it means if it's at 0.125, that's 1/4 of the value of what it was what our source value is. So all we have to do to fix that is to add, again take this and set this back up to 4, which is 4 times 0.5, which should be, when we get out this and roll over it, lo and behold, when we look at our L on the screen down here, if we look at that, it says it's 0.5. So we know that this gets us to the value of our original source image. When we go back and forth between these two, we know that this multiplying it by 4 brings it up to the value that we want. But the problem we run into is of course, when we bring this bump map up, we start seeing that it can get very, very bright very, very quickly, and the darks don't look really dark, and the brights look too bright, in my opinion. Which is why I said that we want to really, bring this up to, as I said, we're going to treat 100 as 100%. All right? Excuse me. So, as I say, I like bringing it down. 4 actually gets us up so that it's a perfect 1-to-1 match for a mid-gray. But I actually think we wind up with a better map around 2 or 3. We wind up better. But that's a user thing. That's what the logic is behind it. I wanted to make sure we were clear on that and why I was saying it was a multiple of 4, so you were aware. All right. So here we have a map. We don't have a light source, and I said that our light source is determined by the directions of our U's and our V's. The higher the U value, or the higher the V value, it determines the direction of our light. Okay, so how do we change our light direction? Well, the easy way is to obviously multiply this against some value in between here. And it really doesn't matter where we do this. I'm just looking at something here. What do I have here? I just realized I had a... Oh, right. I was going around playing with something. All right. Right. Let's... Right. So, I'm going to... Because this is my value, and I want to invert whatever comes after this. let me just think about this. Do I want to do that? Let's just go with it. Well, I don't think it really matters where in this line it occurs. We'll test it out. So what we're going to do here is we're going to put in and I do want to point out before we go any further, let's look back at our bump map just to show that this does not work with iDistort. Let's see what happens if we put iDistort in here and try to, whoops, that's a solid, not an iDistort. iDistort. Sometimes I swear I don't know why I get them. Anyway, so there, we've hooked it up. All right, so we have the same. Wait a minute, I've got it reversed. I've got them. Okay, UVs, go to the UVs. There we go. Now we're going to go in here and we're going to look at it, and it actually doesn't look any different. In fact, it looks just like our original image. So iDistort in this situation probably isn't going to do much. Let's see if we put some type of image on top of here. What does it do to the image? Let's put a checkerboard, because it's always good to see how this impacts our checkerboards, right? Our textures themselves. So we put it on here. We can see that this has absolutely no effect. Let's try putting it on with the original one. Nope, no effect. UVs, despite this being a UV map, and despite... Oh, wait a minute. I'm sorry. I fibbed. I forgot we got to also increase our UV scale. Let's put this to 100. And because we're working from... I think we're working from 0. Well, we're working from 0 here. There we go. Okay, we are seeing something. Let's just see. Yeah, let's just see. Let's just see if we can. So we are getting a distortion. Let's see if we bring it down. It really doesn't do much with the low one. So okay, so it can give us a distortion. It looks okay. Looks okay. I'd say we'd want to probably bring this down a bit to lower it. So we might be able to bring this down and use this to distort our image, and then use our STMap on top of that to get our value or a bump off of it. But let's see what this does with the. Let's put the STMap in here. Let's bring this back up to 100% bump. And let's see what happens if we use our STMap, or as our checkerboard as our thing. And we'll notice that, lo and behold, we're really not getting anything here. We're getting values. We're getting something very different. And the reason is that what it's doing is remember, this is sampling the values off of our image, off of our source image. So it's picking this, the STMap works off of the idea of having an input value, and it picks that value from random points across it. So some of these points are actually getting darkened by the light gray, and some are getting darkened by the dark gray, and some would, in theory, get darkened by the yellow pixels. But we're not seeing them very much in here because, well, it's not going to do it. But by giving it a solid color, what it's doing is just pulling it all the same thing, and all it has to work with are those gray values. So it brightens it and darkens it based off of what a multiplier is, or what these values are. All right, so that's why we're getting this lovely, what basically translates to a bump map out of a form of light, or perceived light. It's not real, it's fake. This is 100%. I'm going to tell you, this is not really fully directional control. All right, but so how can we control this light a wee bit? Well, we can control it by putting an SEEXPR in here. And by the way, this is a weird thing. I tried doing this using something other than an SEEXPR, and it doesn't. Using color maps does not work. It actually causes. I tried using a merge node, doing a multiply, and it should have worked, but it didn't. And I don't know. I'm not 100% sure why it doesn't work, but we're gonna just leave it be. What we're gonna do is put an so we're gonna put an SEEXPR in here. It's going into input 1. Obviously, we want the output to be on a value of 1. We don't want to. Oh yes, and yeah, we do know that we don't want back here. I just want to point out we have a solid alpha channel, so we don't really need the alpha channel out of the SEEXPR. So we're gonna just set it to 1 as opposed to the input source. All right, because we're just using this for light, or for simulating a form of light and light direction. So we know that with the SEEXPR, what we can do is we can put in UVs, but what we want to do is take the UVs that are coming in from input 1 and multiply them times something that we can control it. Well, let's just for the moment just say we know. Okay, so the I think it's just CS, C small s, is the input source. So the RGB script, if I'll put that in, all that's doing is it's taking the color source and it's putting it, that's coming in color source 1 for input 1, outputting it directly. So I've changed absolutely nothing, but here's the trick. Now I can do -1, which will invert whatever's coming in and reverse it. So right now, when I pull my mouse away, we can see I've reversed our UVs, and now the whole image, the colors, what used to be on the bottom are now on the top, and what was on the left is now on the right. So that's what's that done to it? Well, if we, let's just take a look. If we disable the SEEXPR, we see that we have what we originally started with. If we enable it, we sort of reversed it. Or did we? It looks a bit weird. It almost looks like we're getting a similar result, but in, well, it's hard to say. Truth be told, we should be getting the reverse, which means that, or at least an invert of the image. It could be. It's debatable. It's debatable. This is still a work in progress, but we're getting something that, in theory, should be. Well, here, let's do some more work with this. Let's start trying to see if we can change things. What if, instead of doing multiplying the a 1 against this, why don't we take a color parameter here and create a new color parameter called color 1? And let's take color 1 and let's make it 3 different variables. For right now, let's set the color 1 R to -1, color 1 R to -1 on the green. All right. So, and then we're going to take this and, oops, I just made a boo-boo, or accidentally dragged something someplace I did not want to. And instead of multiplying, so yes, times -1, let's multiply it times color 1. By doing that, we're basically now transferring control of what controls these UVs to these controls, right? So if as I gradually move this up, we can see that I'm transferring or removing the red or lowering it so that it eventually becomes neutral green, and then I'll start adding it in the opposite direction. All right. So we basically have given ourselves the ability to sort of control this. Now I'm going to tell you, as I said before, this is a bump. This is a pseudo bump. This is something that we can use, but there's a limited a limited amount of what we really can do with this. All right. So now we've basically, let's just see what happens as we do this. Let's pull this down slowly. All right. As we pull this down, we can see that we're really not going to black at the bottom. So what this is implying is that this what we're seeing here might be a blend of the two maps, so to speak, as opposed to, well, it's hard to say. Anyway, I'm still working on what the key thing is we get something from this that we can use as a bump. We definitely have something here we could pull off some form of rudimentary lighting effects with out of this. I'm not going to say this is a perfect light map, but we can do other things with this. If we, for example, were to take this value here and drop it back down to, say, 1, where we were over here, and let's do something else. Let's say we take the output of this, which is 100 right here, all right? And what happens if we were to add something to it, all right? Or average something with it. Like, for example, let's put a merge node in here and do one of our classic things, like, say, oh, I don't know, let's add a let us add a radial. Oh, RAD, there it is, radial. All right. We'll take our radial and we'll pipe it in here, and we put it over on top of it, and we're just going to leave it in white for right now, but we are going to shrink it down, and we're going to bring it down to, you know, some reasonable value. Let's take it down to 5 something. There we go. So we got 520. That's pretty good. We'll center it, get it there. And instead of saying over like this, The problem we have is that it's not, this is overriding what we have there, which will just sort of wash it out. So we lose all the texture. Instead, what we want to do is something that we get a mixture of the two. So now, by doing what I've done, you can see that I've officially darkened this so that it's half as bright as it was before. But it makes it so that the light gets added onto it. So let's see. Let's see. Maybe we can take this and double the value of our input, and then we wind up with something that may be the same as what it was before. Let's take a look. I want to copy this. Let's grab that, copy that over here, put that there, and take this one down to 100. All right, let's take a look at our values, and indeed, so now what we've done is by increasing that to 200 from 100, we have made it so that we can put this light on top of it, pseudo light, mind you, and let's see what that does to the overall thing. And oh, wait a minute, it didn't actually light it. Oh, or actually, did it light it? It may be. Oh yes, we're lighting it with a negative light. So the problem we have is that perhaps what we want to do is, instead of having the invert happen where we had it, maybe it needs to happen before this merge node. That way we can control the light, the directional light, before we put this sort of pseudo on top light above it, and then do the math to actually reduce it or to work as a bump. So now we have something that could, in theory, looks kind of like a type of light on top of it, or at least a straight down light. That's an interesting potential addition to it. We could, in theory, take and maybe put into this, we could use do something similar like we did last time with an STMap, and maybe, I don't know, my brain's doing all kinds of weird, funky, evaluation. What happens if we were to take and apply? I'm just looking. I didn't want today's one is going to be a little short, but anyhow, I wanted people. I don't want to go too long today. I wanted to just introduce this as a thing. So what we've got so far is we've got something that we can control. Yeah, I do want to point out that if we put these at both at 0.5, say, and 0.5, we wind up with something. What we may have to do, and this is an opinion here, what we might need to do is add something, have some type of control. If we wanted to use this as some form of light source, we may actually have to control this more with a something that increases the multiplication of this above and beyond what it is. So, in other words, say that as one decreases, we may have to increase some value relative to it. It's just a thought. Again, I haven't fully explored this all the way. What I wanted to do is bring this up as a type of lighting, because I have a feeling that the lighting that we're seeing in the relight node is actually based off of the same concept of lighting. And I wanted to point out that this is actually because the problem we run into is as we get these to yeah, hold on 1 second. I want to put this up to 1 and then bring this back down. One of the things that I thought was interesting is when I was exploring this is that if I believe, yes, here's an interesting thing. Right now, notice that the dark areas here on the left-hand side of the screen, they're black, all right? And the right-hand side are, well, relatively light. Let's move this out of here for the moment. I want to remove this from the equation, so to speak. Bring this back here to make sure I'm on 100. Right. All right. So with our SEAXPR, if we if we have this at 1 and 0, it looks like there's something coming in here. 1 second. I just want to see something here. Put this up to 1 and 1. Yes. We get a bit more gray, light gray up in this area. But if we look, when we bring this down to 0, we wind up with something that is hot over here, which implies that we are not getting true lighting over this. We're not getting a solid shade, a consistent shade. What we're doing is we've lost one of the aspects of it, potentially, in this, and which is unfortunate. But we do get something that if we were to say, let's pull up change our source from an SE noise to something more like a text node. Let's do a text node, and let's just, for the moment, I want to do something here where we'll just make this a bit bigger. I don't want to make it go overly complicated. Let's get that bigger, nice and big, nice and big. That's nice and big. And what's the other thing? There was something else I wanted to do. I centered it. Oh, right. I want to change it from... I don't know if you guys are seeing what I'm doing down here. I changed the font size to 164. That might have been behind my picture. Or, and I'm going to change the weight to ultra heavy so that it's nice thick text. And then we're going to use this as our source. So what we're going to do here is hit a period off of the SE noise so that we get the nice dot node. Put that in here. We're going to put a blur underneath this, blur here. And we're going to go back here. All right. And look at our result. And we can see we'll wind them up with something that's embossed. All right. When admittedly it's embossed against whatever our source was over here, which by the way should be higher. If we put it up there, that's the true thing. We're getting something that's more or less an embossment. Make sure we have. Oh yes, we want to also set this to 1. So there we go. So if we look at this. It's actually too hot, in my opinion, now that I'm looking at it. Maybe this is definitely... Our value here is definitely too high. I think we might want to put another 0 in there. Or 2. Either that, actually, let's maybe... Perhaps this is too hot. Let's take this value down from 4. No, we're getting something that's too hot. Anyway, we're not going to worry too much about this, but you can see that we're clipping in here. Our lights are definitely, our blacks are clipping in here, which is not something, it probably means the whites are clipping as well, but it's harder to see the whites clipping as we can see the blacks. Anyway, let's take a blur, the blur node, and increase this in size a bit just so that we start seeing this. And whoa, too much. Let's take that up to 11. Pull this down a bit. And well, the reason I wanted to bring this up, this can be fixed, by the way. Let's see something here. I just want to take, I think if we bring this down to like 50 down, let's bring this down a lot. Oh, there we go. 10 9 8 7 6 5. Wow, this is really very, very strong. All right, we probably do need to plop in some extra zeros in here to get that really. There we go. We're starting to get it so that that's more what I'd expect from it. Anyhow, let's see if bringing this up to 100. The key is you want a nice range. You want it to look nice and gradual. You don't want it to clip. And we're starting to get that. It's looking pretty good right in there. Anyhow, we could debate that. That can all of this can be controlled by, you know, adjusting these values here. The reason I wanted to bring up the using the blur node, etc. for this is to show that if we were to use this, let's bring this up a bit more. I want to have quite a bit more of that blur for the font so that we wind up with a much more pronounced emboss. Anyway, what I'm showing here, the reason I brought this up is because from a lighting standpoint, we can see here when we use this the EXPR to control the light, we can use this to get a few different types of lighting patterns. Right now we're getting a nice lighting coming from the bottom left, which is probably the most useless from the standpoint of this. What would be is more useful is if we reverse the green so that the light is coming from above. Now we get something so that it looks like our light source is up to the left as opposed to depth from below, which could be useful. We could use this as actual, lighting in a lot of situations. So that's good to know. This simulates basically by having it set to a color of 1 and -1, 1 on the R and -1 on the green, or 1 on the U and -1 on the V. We wind up getting light, or the equivalent of a lighting effect that's coming from above. Likewise, I also want to point out that if we set this to -1 and -1, we wind up with it coming from the opposite direction. We can see we have nice lighting on the top, nice lighting on the side, on the right hand side of the text, and then we get nice shadows on the other side of the text. So we can get lighting from both sides. Where it starts to get wonky is when we go down to 0. All right, when we set either of these to 0. When we go to 0, what happens is we lose all detail altogether on the side-to-side movement from this, and that is the problem with the system. Is that it doesn't really. There is no such thing as 0. If you actually had it, you should be getting some form of deviation, and we would expect it, and the only way we can do that is to slightly offset it by just a smidge, and then what we would have to do is set up an expression so that when it got to 0, it would replace the 0 with a little bit of light from the other side, and then switch it from the 0.1 there to -0.1, and make the jump, eventually, or even well, that was a bit drastic actually, but maybe I don't know, 0.0. I don't know how far down we can go while still maintaining a little bit of an edge. At this point, I think we've lost all semblance of an edge. So you want to have it so that it's visible, or at least marginally visible, before you switch over to the other side. So something like that, and then you'd shift to the other side in your thing, and that would keep at least a little bit of the shadow detail. The problem is we still lose something in this. We're losing a bit of the shadows. It really isn't a perfect lighting solution. This is because it's a pseudo. This is what was I say? Most of this is about, we're doing something. We're distorting this based off of UVs as opposed to an actual light. And I think, as I say, I think this is working off of the same methodology that the other one was. And I brought this up because I wanted to demonstrate that this technique, we can mimic it, but it's a flawed technique. I think we wind up with the same thing, but we could still pull off lighting. The reason I wouldn't use this on clouds like we did, we could use it if we were only doing a simple thing, but on the clouds, the problem we run into is that the clouds, we wanted to operate this procedure to operate very, very quickly. And unfortunately, this EXPR, when we do this lighting here, it actually takes a moment, a bit more processing time than using a merge node does for doing a similar operation. Unfortunately, the merge node doesn't produce the proper result, which is why I ended up having to use it. The merge node clips the blacks for some reason when you do the multiply, which is unfortunate, or at least that was my experience. I was unable to reproduce it properly. So, right. Actually, I'm going to call it here. So, right, we're going to go back. I had a thought just dawned on me. So, right, I just wanted to go over this because we're going to be doing some lighting stuff, some other lighting stuff. There is another technique in Natron to light. We're going to use a GSL system that we've used to light before that is going to be probably the most accurate form of lighting currently I'm aware of inside of Natron. But this is a way of getting some form of bump out of our textures, which is one of the things, was the point of this, was that how do we get from those bump maps, how do we turn them, or how can we turn them into some form of bump map? And I'll just show a simple way. It's not a perfect way, but it is a simple way, and it can work. You just have to be careful. You have to know the limitations. It's about exploring it, knowing limitations. We have, oh yes, we don't have the volume image up anymore. Anyway, thanks for watching. Keep on Natroning.